Hi, and welcome back to our course. Today we are going to start on Module 2. I'm sure you remember that we talked about course objective and programming paradigms in our last lecture and understood function programming a little bit. Then we were able to differentiate function programming and object-oriented programming models. We will take a look on why we should choose Scala to code with, and then we'll start and get our hands dirty by writing some Scala code in Scala REPL. Why to wait then? Let's begin our journey by taking a look at module objectives. In this module, we will start with why to use Scala for our applications. There are more reasons to that, and we will talk about them later. We will go ahead and know about Scala's offering to us, the developers. Because of Scala's popularity and multiple paradigm features, it's being used in many other web frameworks and toolkits, even front-end frameworks like Scala.js. We will discuss about that later. And then finally, we will start by doing a bit of Scala code in Scala REPL. I'm waiting for that. We will set up environment for Scala programming by installing IDE for Scala. We will use IntelliJ IDEA that. We will learn about Scala's basic data types. If you are coming from a Java background, this won't be much of an effort for you. Scala is statically typed, and our next topic will be type inference. We will discuss about control structures in Scala, if and else if and pattern matching and all those constructs. Then we will talk about looping constructs in Scala. Finally, at the end of this module, we will discuss functions. Scala is also a functional language, and there's more to functions than any other object-oriented language. We will discuss about anonymous functions and procedures. So, you see there's a lot coming in this module. We will be covering all of them. I'm sure that you're going to get along with me on this journey. So let's start with our very first topic, why Scala? We have talked about Scala's capabilities to write robust and concurrent and scalable applications. You have already seen some of its capabilities, like it supports immutability and referential transparency. But there's more to Scala. By saying more, I mean it. Scala is concise. It's compatible, high-level language, multi-paradigm, and easier for parallelism. So let's discuss them one by one. First, Scala is concise. I would say anyone who has some programming experience with Scala can explain that to you. The comfort this language provides to not only programmers but also developers who are constructing libraries. Programmers have reported reductions in number of lines up to a factor of 10 compared to Java. Scala has concise syntax. There are no semicolons mandatory, and thus less noisy syntax to write. Much of the boilerplate code has been removed. It makes it easy to write libraries, and as I mentioned, programmers are able to reduce the number of lines. And fewer number of lines not only means less typing, but also less efforts at reading and understanding programs. It means fewer defects. You can understand this by taking a look at the underlying code snippet. This is written in Java. See, we have a class named Avengers. We have two private attributes, Avenger name and Avengers character. Then we have constructor named public Avengers, taking two parameters, Avenger name and Avenger character, and then we are initializing them. This whole code can be written in Scala in just one line. Say, class Avengers, Avenger name, and then Avenger character. That's it. That's how we define. All the boilerplate code exists at the backend. Scala compiler will generate that for you, so you don't have to worry about that. That's the conciseness of Scala. I think you have some idea about Scala's conciseness now. How a lot of needless code has been removed, achieving the same result. Scala's type inference is also a contributor to its conciseness. We don't have to repeat type information again and again, and thus it can be left out. See, Avenger, and we are creating an instance of Avengers with two parameters. It's understood that val's type is going to be Avengers, and hence it was left out in Scala. Same can be done for other primitive types such as integer, float, or other classes. In Java, you have to explicitly write the same thing again and again, like Avengers, Avenger is equal to new Avengers. You can see that it's not good. If you know about Java's reflection property, you may already have an idea about how type inference can be a big relief for us. Different aspects of library classes can be separated out in traits, and then it can be mixed in flexible ways, and we call it mixins in Scala. It makes development easier. If you're not getting it, don't worry. We will talk about it when we'll discuss about Scala traits. Those are like interfaces in Java, if you know Java. One more example of Scala's conciseness is case classes, which is equivalent to Java's POJO, plain old Java object. And if you're wondering what a POJO is, then you can think of it as a simple class with some properties. For example, our Avengers class, which has only two attributes, Avenger name and Avenger character, can be called a POJO. Pattern matching makes a lot of control structure needs easier. And you will be using pattern matching a lot while programming with Scala, I would say. You can see that using case keyword, we are trying to match Avengers or X-Men. And that's easy for controlling, working with POJOs and all those things. Scala is compatible. You know, Scala is a JVM language. And if you don't have any idea about what is JVM, then for simplicity, here's how you are going to understand JVM. JVM is called Java Virtual Machine, which converts your Java programs to bytecode so that machine can understand and perform operations with your code. Simple, isn't it? And welcome Scala on JVM. Scala is a language which runs on JVM and compiles to JVM bytecode. So, you won't be seeing much difference between compiled Java or Scala code. Scala is designed to interoperate with Java seamlessly, and you can access all Java methods, Java's fields, inherit from Java classes, implement Java's interfaces, and everything will work smoothly. Indeed, Scala is heavily reusing Java's types such as integer and strings, etc. etc. We are heavily using in Scala. You will feel good when you get to know that Scala is not only reusing Java's types but also dresses them up to make them nicer and richful. Scala strings supports methods like toInt, toFloat, which, as you can assume, converts strings to its counterpart. This is not possible in Java, and possible here because of a beautiful concept named implicit conversions. Scala is high level. I always believe that important systems may need complex code, and for that we need manageable constructs. A simple example of what I'm trying to convey is strings in Java are low-level entities that can be stepped through character in a loop. Scala treats the same strings as high-level entities and can be queried with predicates. And if you don't have any idea about what a predicate is, let me tell you that a predicate is a function with a Boolean result type, which checks some logic or condition and then responds true or false. Scala's functional programming style also eliminates aliasing problem encountered in imperative programming. Aliasing happens when multiple variables refer to same object. This gives rise to questions like, does changing a variable r.x also affects s.x? Immutable data, on the other hand, can be shared freely. And this difference is significant when we write concurrent programs. You can see this example where we are trying to reassign an already defined value named x, and compiler is not letting us do that. That's how aliasing is not a problem where we have immutability concept means in Scala. Scala is statically typed, a bit advanced to understand for beginners, but believe me, it will be helpful if you understand the difference between a dynamic and statically typed language. Scala's static typing system is very versatile. A lot of information as to program's behavior can be encoded in types, allowing the compiler to guarantee a certain level of correctness. This is particularly useful for code paths that are rarely used. In statically typed languages, type checking is done at compile time. Program execution can be made more efficient by omitting runtime type checks and enabling other optimizations. There are some disadvantages though with statically typed checking. Like it may reject programs that are well behaved at runtime but can be determined to be well typed at compile time. In a statically typed language, any bug that can be caught by compiler will be caught at compile time before the program has even started running. By the way, statically typed object-oriented languages have often been criticized for being needlessly verbose, and indeed they are. Java, have you seen? Why would you write again and again some construct like Avenger class, Avenger reference variable is equal to new Avengers, and then you're passing parameters to initiate a new object of Avengers? Now let's talk about dynamic language. A dynamic typed language cannot catch errors until a particular branch of execution runs. So a bug can persist for a long time until the program runs into it. Many times it is enough to specify the types of the arguments and of the return value of a function. The compiler can then infer type for all the variables defined in the body of the function. Scala code is usually much more concise and readable than the equivalent Java code without compromising any of the type safety. Some of the benefits of Scala being statically typed language are like it has verifiable properties. We can refactor our code whenever we want without compiler being angry with us. So next is Scala is a multi-paradigm language. Just because Scala has the best of both worlds, object-oriented and functional, it's a very powerful language. It's one of the very few languages that can support both paradigms and still works effortlessly beautiful. It has capabilities such as strong encapsulation and abstraction. Then we have the concepts of classes, objects, and traits and mixins. And then it supports functional constructs as well. Has a lot many powerful tools to offer like referential transparency, immutability, anonymous functions, procedures, high order functions, currying, etc. And that is the reason we have a very powerful language that can be used in many ways, libraries for writing apps. So next is easier parallelism. Scala provides us mechanisms to take advantage of parallel architectures. For example, parallel collections are actor constructs which talk in terms of application state and communicate by passing messages. See, I want to make a point that favors us, the developers, that we use these constructs like actors or parallel collections, immutable data structures that interacts parallelly. We limit the reasons possible when something goes wrong. If an actor misbehaves, we know the problem lies in either the code for this actor or one of the messages that the actor receives. Other reasons to choose Scala are like its rich features like configurability, maintainability, computation on demand, concurrency constructs such as actors, etc. etc. These make Scala desirable, and you'll definitely want to try out this in your very next project, don't you? So let's summarize what we have learned in this lecture. We started with the reasons that make Scala cool language. Reasons to choose Scala for its feature-rich constructs and multi-paradigm functionalities. Very few languages are there with such power and robustness. Scala is one of them, and that's the reason for its popularity. We discussed all those reasons such as compatibility, being high level, statically typed, and etc. in our lecture. So that's it for today. In our next video lecture, we will talk about Scala's features, and then we'll take a look at frameworks written in Scala. So I would want to wish you happy learning. Thank you. Bye-bye.